Now we will be writing and evaluating the truth value of an inverse and a contrapositive. Here we only have to work on one statement. If today is a weekend day, then tomorrow is Monday. So remember from our two examples, A and B, we'll need the converse of this statement. And we have here, we can say this is P and this part is Q. So when we take the converse, we say if P, if not P, then not Q. And the statement for that is, if today is not a weekend day, then tomorrow is not a Monday. Okay. Then we will be doing the inverse. And if you remember on our definitions, the inverse is basically switching the positions of P and Q. We'll start with if Q, then P. So we will switch the statement and say, if tomorrow is Monday, that was our Q, then today is a weekend day, and that was our P. And now we will be doing the contrapositive. Now, we obtain the contrapositive by definition by negating and reversing both of the hypothesis and the conclusion. So we will do is not Q, if not Q, then not P. And with this contrapositive statement, we will say, if tomorrow is not Monday, then today is not a weekend day. And I don't know if you have noticed, but for the contrapositive, we just took both of a converse and an inverse and kind of matched them together. And that's how we got if not Q, then not P. Now we will be working with biconditional statements. The definition states that a biconditional is the combination of a conditional, if P then Q, and its converse, if Q then P. And so the resulting compound statement can be read as P if and only if Q. And as you might have noticed in the bottom, this graph represents the truth table. And within these truth tables are the truth values. So the T represent true and the F represent false. So with the way that we can read this is that P if and only if Q. So when P is true and Q is also true, then this would mean that our statement, our biconditional statement, is true overall. So, and with our second row, if P is also true, and Q is false, this would mean that our biconditional statement is false. And for our third row, if P were to be false, but our Q is true, it would still mean that it was false. Our biconditional statement is false overall. And as for our fourth and last row, if both P and Q are false, then that would mean that the biconditional statement is true. Now we will be writing and evaluating a biconditional. We have here our statement. If two lines intersect at right angles, then they are perpendicular. If two lines, we can draw this. Here's our first line, and then our second line. It's not perfect, but, and here they intersect, meaning this intersection in the middle has a right angle. These are all right angles. Right angles means 90 degrees. And we have learned that if two lines intersect at right angles, they are perpendicular. So we would say that we have P, which is true, and Q, which is also true. And from our truth table at the top, we can see that if both P and Q are true, then that would mean our biconditional statement is true. So that biconditional statement is true. Now we will also identify the conditionals in a biconditional. We have here our statement. The product of two numbers is negative if and only if the numbers have opposite signs. So we have here two parts due to this. We have here our P, and we have here our Q. So in this biconditional, we can say that the product of two numbers is negative would be identified as P. And the second part, if the numbers have the opposite signs, is our Q. Now for this statement, you can notice that we could also switch the P and Q. This could also be our Q, and the second part can also be our P. So when we're writing our statement with the if and then, we could say that if Q, which is the numbers have opposite signs, if the numbers have opposite signs, spell that wrong, signs, then the product of the two numbers is negative. Now, the other way of writing the statement is also with our original P and Q, which is if the product of two numbers is negative, then the numbers have opposite signs. And so that leaves us with the conclusion of our lesson dash 5 conditional statements.